In a previous video, I had the great pleasure of Ian walking me through how an AFDD works at the Ludum Palazzoli factory that I'm still in here. If you haven't checked out that video, I recommend you do. It'll be in the eye above my head, and I'll also leave it in the link in the description below. But since we've had dinner and had time to reflect, I'm going to pose some more questions. Is the role of the AFDD actually to protect the plugged-in equipment on socket outlet circuits up to 32 amps in the locations that we know are specified in the Amendment 2? Or is it really there to protect the fixed wiring? Ian?
Well, as you know, BS 7671 is written around fixed installation, the fixed wiring part of the system.
Yes.
And now, with AFDDs, and particularly the mandate on socket outlet circuits,
yes,
we're also looking at those particular plugs and sockets and the trailing leads that are then connected to them.
And that reminds me, doesn't it, of when we looked at RCD protection being introduced, because it was suggested, wasn't it, the customer will plug their lawnmower in and run over the lead. They'll plug their hedge trimmer in, maybe cut through the lead and grab hold of it, and therefore the RCD will operate and hopefully reduce or prevent the risk of electric shock. However, the same rule applies, that an RCD was there to protect the fixed wiring and not the plugged-in items. And I've got a feeling the AFDDs are going down the same route. So if we think about what you said in the previous video about carbonisation of the material, so we had both the copper and carbonisation process in order to develop that arc. Imagine I'd wired my ring final circuit in mineral insulated cable. Yeah. There is no PVC around the conductors, is there, Ian?
There isn't, and it's unlikely to produce a carbonisation on that type of insulation.
However, BS 7671, if it was in one of the 4 locations or a recommendation in domestic dwelling, would still say that that circuit would require AFDD protection at the consumer unit end, yet there's no chance of carbonisation. So that leads me to the conclusion that I believe that it's actually there also to protect the plugged-in lead.
Right, I mean, here's a good example.
Okay, let's have a look here.
And to be honest, that actually come out of our factory.
Okay, did you plug an immersion heater in it? Look at that. Yes,
we did have a fan heater plugged in that, running for a few
okay, and
as I
look at the plug there, that looks like it's always the neutral. I never know why. It is the neutral. That obviously that's caused a little bit of warmth, I would suggest.
It has, and that's happened slowly over a period of time.
But that's not the responsibility necessarily of BS 7671, is it?
No.
Okay, we'd expect the fuse to operate, obviously, and disconnect the appliance. But when you took this item, okay, and we've got the footage, haven't we? And we've seen that footage. When you took the item and you plugged it into a circuit protected by an AFDD, what was its first reaction when you turned it on?
Immediately I put that on the AFDD to protection, just out of my own curiosity, honestly. It's brand new technology. I wanted to see, I mean, that socket in the factory there is protected by an RCBO.
Okay.
So, and we'd only found that by inspection, really.
Okay, you mean you tidied out the office of the person that was in and found it then?
But this, I mean, the AFDD, immediately, I put it on out of my own curiosity, and as soon as I connected it, it tripped the device.
Okay, and looking at that, there's obviously a huge amount of heat being generated. In the previous video, we saw an RCBO with the same type of fault that we put on an AFDD. We saw the AFDD trip. We saw the amount of energy being generated, and obviously it didn't trip the RCBO. This was on a non-AFDD circuit. It didn't trip it, you found it.
Right.
Yeah, and obviously we put it on. So that goes back to what I suggested, doesn't it? That the AFDDs, and I'd love your thoughts and your comments about this below, because we can start that discussion. Okay, are they there to protect the plugged-in equipment? Because we know maybe you might get an old appliance, you might have this issue, okay, where we're going to cause a problem from the socket onwards rather than backwards, and the AFDD has been not necessarily smuggled in, but introduced. Would you say I might be on the right lines there, Ian?
I think you might be, Gary.
I probably am. So with this, we had the carbonisation, didn't we? So we had PVC, we had carbonisation. As I said, if it was wired in mineral insulated, okay, and there was a fault in there, there might not be that carbonisation process, and it's caused the device to trip. So yeah, it's one of those for me. I think this is similar to the way we did RCDs. I think it's going to come in more and more to actually start protecting the equipment that's plugged in, and people from themselves sometimes, isn't it? You know, you go off and you perhaps buy a second-hand fridge, you plug it in, as long as it works, you're okay. But of course, what's happening with that appliance?
Yep.
That is really, really interesting. Again, it's your thoughts. Okay, do you believe that BS 7671 are going to slowly bring in AFDDs in order that on socket circuits, that things that are going to, do you think they'll come in on lighting circuits? We discussed that you need how many amps for an AFDD to operate?
2.5 minimum threshold?
Yeah, so if you think about a domestic dwelling, lots of LED lights, would you say that you're probably not going to get to 2.5 amps?
Not likely.
No, not likely. So it'd be interesting to see how BS7671 handles circuits like that. But it seems clear to me that actually AFDDs on socket circuits could well be there to protect the load into equipment as well as the circuitry, but that carbonisation of the PVC on the flex is key for tripping, and we see that in the previous video. And I recommend, if you haven't seen it already, again, it was in the eye above my head and the description below, you go and check that out. We'd like everyone's thoughts and feedback. We may do another round table. We may bring in someone like Shahid, and we may bring in somebody else, okay, to give us that round table discussion. But your thoughts and comments on this video will drive where we take this one to the next one, so please leave them below. Again, thank you, Ian.
Thanks very much.